Assalamu alaikum. Welcome to my channel M.Asif Math Corner. Today we will study about automorphism is a group in group theory. Let's start. Automorphism is an isomorphism. We know that what is isomorphism. Isomorphism is a mapping between two groups, and that mapping should be one-to-one and onto, and also homomorphism from a group into itself. If this isomorphism is from group to group itself, then it is called automorphism. It means that automorphism is also an isomorphism, but it is a special case that is from group to itself. Is phi is a function from G to G is an isomorphism. Then it is automorphism denoted by AUT of G, or you may say that automorphism on G. The set of all automorphisms from G to itself. We have to prove that automorphism is a group. By definition, an isomorphism of a group G onto G, as we studied, called automorphism. F is a function from G to G is defined as if f of AB, then it will be equal to this. This is called homomorphism, and if it is onto and one to one, then it is called isomorphism. F of A dot B is equal to f of A dot f of B. Order is preserved. Operator is preserved for all A comma B belongs to G, and it is denoted by AUT of G, or automorphism on G. Let's come to the proof. Let a function is defined from G to G is one-to-one and on-to mapping. This function is one-to-one and on-to mapping. Let's automorphism, all automorphisms, all these functions make the automorphism. All automorphisms are equal to A is a set of all automorphism of G. Now, because we have to take a set, and that set we have to prove that that set is a group or not, we will apply all the four properties: closure law, associative law, identity should exist, and the inverse of every element should exist. Then that set is called group, or then these all automorphisms are called a group. Let's suppose that F, G, H are the elements of automorphism of G on G are equal to A. We have to prove that automorphism is equal to A is a group with respect to multiplication. We are going to prove it with respect to multiplication. Let's start. We will apply our first property, that is closure law. For closure law, we introduce two elements, F and G belongs to A. So F of G of AB will be equal to G of F of AB by associative law. So as we defined earlier that it is a homomorphism, so G of F of A, F of B, and then G of F of A into G of F of B, hence proved that G of, this is small letter G, GF AB is equal to GF A and GF of B. Hence it is automorphism of G, thus the closure law hold. It means that these individual elements, when we multiply, and this is the form of homomorphism, and it is one-to-one and on-to, that's why it is isomorphism, and it is from G to G, that's why it is called automorphism. Next property, that is associative law. We know that associative law is a hold in general. So let's F, G and H belongs to A, all automorphism on G. The product composition of a function is associative in general. We know that associative law hold in general in all type of sets we study. Hence the product law of automorphism is associative. No need to prove it or no need to explain it. Just you can write that the product of automorphism is associative as well. The next property is existence of identity element existence of, let the identity function I from G to G, if 1 belongs to G and we put a function y is equal to f and we give the value x 1, then y is also equal to 1. This means that this one will map to 1. So I of x will be equal to x, it is 1 to 1 and on to, for all x belongs to G, or I of AB will be equal to I of A and I of B. This is homomorphism. This is 1 to 1 and on to. Hence, I on G is an automorphism. Thus, the identity exists. Now we have last property, that is inverse. The existence of inverse. Let f be a function. Let f belong to all automorphisms. The mapping, the function f from G to G is 1 to 1 and on to the inverse mapping. If when we have the same function, that's why inverse should exist. What it means? It means that if we give the value 2 to x, then y is equal to 2. Similarly, if we put a function y, fx is equal to y, and we give the value 2 to y, then it is also 2 is equal to 2. If we have the same function, then inverses should exist. That's why when we give it value 2, this 2 will map to 2, 3 will map to 3, and we exchange when this g by this g, then the values also will remain same. That's why the inverse mapping will also be from G to G. So therefore the F inverse is an automorphism. Thus the automorphism is a group. I hope you understood. If you like my lectures, then please share my videos and subscribe my channel. Thank you so much.